Hi guys, my name's Mannix, and what I'm going to be doing today is delving into the structure of the thesis that I did with Philly last year that you guys just read, and I'm going to be explaining to you how to conduct your own extension of my thesis. So, the basic design of my thesis is that it was conducted as a replication and extension of the book article Baron and Szymanska from 2011. And it's totally fine if you don't know what that means, and I'm going to be explaining that to you now. So, some people like to donate money to charities. Charities help people. So, if you donate money to charities, presumably the point of you doing this is to help other people, right? If you donate money to charities, you're doing it to help people, I assume, right? But are we sure about that? Do people really donate money just to help other people? Or are people in general affected by other considerations? So Baron and Szymanska wanted to investigate whether people really donated money just to help other people, or if they are affected by other considerations instead. So firstly, what they did was build a model for what the best and the most rational way to donate is. They state that the best way to donate should be to maximize the amount of good that is done per X amount of money donated. This is a concept called cost effectiveness. So, if you wanted to really help people with your money, and let's say you had $1,000 that you wanted to donate to a good cause, the best way to donate must be to maximize the amount of good that is done. You have to donate to the most effective charity, which is where effective altruism comes from. So, if there are two charities in front of you, A and B, and one helps, for example, 1,000 children with $1,000, and one only is able to help 500 children with those $1,000, then the most rational and perhaps the only correct decision is to donate to charity A, because you'll be able to help 500 more kids with the same amount of money, assuming that each kid is helped in the same way and the same amount. However, on the other hand, if two charities, A and B, do the same amount of good per X amount of money, so if you donated $1,000 to both charities A and B and they could help 1,000 kids each, there is no difference in cost effectiveness between the two. From a rational standpoint, these two charities are exactly the same, even if they help the children in different ways, if the amount of good that is done to the children is the same. So, if there are two charities, A and B, and they do exactly the same thing, if you prefer one over the other, then there must be something else that's affecting you that made you make that choice, even though A and B are rationally the same. This may be due to any number of biases that exist out there that you've probably heard of in previous classes related to social psychology. So, the question is, how do we study these biases? So, the design of Baron and Szymanska was to give participants two charities, a charity A and a charity B. So, both of these charities have an equal cost effectiveness. So, on average, charity A and charity B do the same amount of good for the same amount of money. The participant is given the choice of donating amount of money to both charity A and charity B. The participant can also decide how much money goes to each charity. So they can decide to give 100% of the money to charity A, or they can decide to give charity B 60% of their money and charity A 40%. So even though they have an equal cost effectiveness, there's something that's different between charity A and charity B, and that will be the manipulation that happens. For example, one of the first manipulations that Baron and Szymanska investigated was past costs. So they had charity A and charity B do the same amount of good, but charity A used to use more money than charity B did. So they found that charity A actually had less money donated to them over charity B, because charity A was seen as a money wasting charity, even though they actually do the same amount of good as charity B does now. So that's an example of what a manipulation could look like. Given that a participant has a certain amount of money to donate, the money donated to each charity should be the same, because logically they should have the same amount of help given to the people that the charity helps. So the way we see if people are biased towards either charity overall is to run a one sample t-test. We're going to see if the distribution is different from 50% to each charity. So if overall we find using a one sample t-test that the average donation allocation between charity A and charity B is different significantly from 50% each, then we know that people are biased towards one or the other on average. These are the instructions that Baron and Szymanska provided to their participants. They told them that the current study is about contributions to worthy causes, such as helping people in need who can't help themselves, such as young children or those who are ill. Participants were then told, imagine that you aren't one of these needy people, and that in fact they had enough money so that it is easy for them to give away money for such causes without seriously hurting their quality of life. They were told to further imagine that they were willing to contribute some of their annual income to such causes. So basically, they were asking participants to imagine donating a lump of money that was commensurate to their annual income, such that this money wouldn't hurt their quality of life. Furthermore, we added in our replication a sentence that says, unless otherwise specified, suppose that all programs mentioned are equally effective and efficient, just to make the questions a little bit more clear. Baron and Szymanska's original study only had 320 participants, which honestly isn't a lot. So we took their study and ran it with minimal modifications and with a larger participant pool size of 1,400 participants. Additionally, we also added a couple of extensions which are tacked on to the original design such that it doesn't affect the original design but also finds something new. So one of the extensions I designed is a manipulation of reputation. So I asked participants about two charities, A and B, which both help thousands of children. Charity A publishes the names of donors and how much they donated on their website, while B keeps donors anonymous. So even though A and B are exactly the same in cost effectiveness, A would give people a better reputation because they can show other people how much they donated, while B doesn't do that. So, taking this question and using the previous study design, I asked participants how much they would allocate to A and B. For this question, I guessed that people would want to donate more money to A, because it publishes the names of donors and they would be able to show other people exactly how much they donated, which would increase their reputation. But I was really surprised to find that actually people would want to keep themselves anonymous when donating money, and they actually preferred B a lot more. And so this is where you come in. One of your tasks later on is to design a question such that there are two different charities, Charity A and Charity B, which are exactly the same in cost effectiveness, but A and B are different in a way that you decide. When you receive your answers, please note that it is going to be coded such that it is the B percentage that's coded, not the A percentage. So if a participant answers that they want to allocate 100% of their money to A and 0% to B, the value is going to be 0, and vice versa. Okay, now that you have your results with you, I'll explain how I analyzed my thesis data, so you'll have an understanding of the statistical tests that I ran. So you won't have to worry so much. This isn't a mandatory component of what you'll have to do. You'll be given a template to analyze your own data in R and in Jamovi. So if R and RStudio are a bit too scary for you, like because it's basically a raw code editor, you can just use Jamovi, it's fine. But I'll explain how I did it so that you'll have a better idea of exactly what the process of doing this was. So the one thing that you need to know when you're provided with the dataset is that you'll be provided with your question name. So the question that you came up with in the end is converted to a question name in a large dataset. So you have to mark this down when you receive it. So in the huge dataset that you'll receive, you'll know where to find your question. Okay, So if you want to follow the way I did it, which is to install RStudio, you'll have to go and download it first, obviously, and you can go and search on for RStudio on Google or whatever, and you can download and install R and RStudio. Just click these two blue buttons that you see on the screen right now, and just download them, and install everything that it tells you to. So the files, you'll be provided with a bunch of files after the Qualtrics questionnaires are done, and you'll be able to see what my files were here on the screen. So, firstly, the .sav files are the datasets. This is what the results will be shown to you as. So, the .sav files are technically files in SPSS, but because SPSS isn't reproducible and people won't be able to, well, check your homework, so to speak, when they want to see how you did. So we don't, we heavily prefer people to use either R or Jamovi, which are reproducible, which means that other people can see exactly what you did with the dataset when you run it. So the SAV files will contain every single response by every single participant that completed the dataset, and you'll be able to use this dataset to import into basically any data into any format whatsoever, like into R, into Jamovi, and so on. So if you want to do it the hard way, which is through RStudio, you'll have to know what the other two things are. So RMD files are the R or R Markdown code files. This is basically the lump of code that you'll be running to generate both the results and also the graphs. And the HTML files are the export files from R Markdown, which combine the text, the code, and results. If you want to go the complex route and use RStudio to complete your data analyses, you'll be able to see something like this once you open the draft that Philly gives you. So they're not really that important. You just really have to look at the first three rows, title, author, and date, which are pretty self-explanatory, and change them to what you are doing right now. After that bunch of code, there will be a really complex looking bunch of code like this, and it's actually less important than the ones on top. It's just loading a bunch of required packages and setting a bunch of settings. But what you really have to note are these two highlighted rows in particular. The yellow rows are the only things you really have to touch. The rest you can just leave because they're set to defaults, which will probably run better on your computer and everything, and you won't really have to care about them. So the first row, the first yellow row, the row that starts with C, open bracket, and a bunch of things in double quotes, this is the list of packages that you're going to install. So the way RStudio works is that it runs a language called R, but R, you can think of R like an operating system. It just has you can open it and you will be sort of stuck there because it doesn't really come with that many pre-installed apps. So the thing this does, the installation of the required packages, is basically like installing a bunch of apps on a new phone. And we have apps like effect size, reshape, and stats expressions that basically do what they say on the tin. So reshape reshapes the data. Psych is a bunch of stat stuff that's really useful for psych experiments. And stats expressions, well, they're expressions for stats. So yeah. Basically, you really don't have to touch anything on this list of packages, but you might be asked to install more dependencies or other apps that you need, like how Google Play services is required for Google Play, you know? And basically, if R tells you to install more things, you can add it to this list of packages. But hopefully everything goes well and you won't have to touch this row. So, but what you have to actually change is this second row, the row highlighted in yellow down here. So this should be replaced by whatever name the data comes back in. So the .sav file, basically if it's called 3052 data.sav, you'll have to replace this row this whole lump within the brackets with the phrase 3052 .sav. And something to note, I'll just go back to this page, is that you have to put the RMD file and the SAV file in the same folder. Otherwise, you'll have to do some sort of complex stuff with it. So basically, stuff everything into the same folder. Don't think too much about it, okay? So next, we're going to be looking at the actual statistical tests. So what we're doing is actually extremely simple. It's just a one sample t-test. That's it. There's no need to be afraid of this. And what we're doing here is basically we're taking the midpoint between A and B, which is 50-50 to each, and then running a one sample t-test to see if the average or the mean allocation to A and B is significantly different from 50% to each charity. So you can see here that I'm running a question called A9 char 1 allocation with a median point of 50 and a confidence interval of 0.095, which is the 0.005 alpha that we all love so much. How you can do this is also really simple. All you need to do is replace this question name, A9 char 1 allocation, which is the bit here after the $sign, with the name of your question that you received from Philly. So basically, just look at all instances of this question name, which might be something different in the template that you receive, and replace it with the question that you asked. So in the case of this question down here, the question name would be study1_answer. So you just replace everything that says A9 char 1 allocation, replace it with study1_answer, and you should be good to go. So basically just replace everything and don't think about it too much. Next, let's move on to how we can generate a nice graph for this item. So this is a bunch of ugly looking code. I know it's really ugly, but I'll try to explain it the best I can. So again, like the code for the data analysis, replace the question name with the name of your own question. So this A9 char 1 allocation thing, replace it with the name of your own question. This df_h1s1 thing is basically the dataset but modified so as to generate the graph. The name of this thing isn't important, but it's important to remember what this thing does. So you can just really keep the name as what it is in the template if you don't really know what to change it to. But do know that this thing is basically a lump of data that you're taking from the entire dataset. So the other two things that you need to note are the lines that says xlab and title. So xlab is the x-axis label, which you should keep, and the title is the title of your graph, and you should change this to whatever makes sense for your manipulation. Once you're done, you should obviously save your code, and what you have to do next is to press this circled little triangle button next to the button that says knit. And then you should be able to see a button that says knit to read the down. If you don't see this button, remember to save your code first, which I assume that you've been doing all along, and this should generate a really pretty looking HTML file, or like something that looks like a website, which looks like this. You'll be able to see a formatted website that contains all of your code and everything that you typed, as well as the stuff that it generates, including the data analyses, the results of those data analyses, and also the graph that you've been generating. Finally, I'd just like to add a couple more things. So, firstly, if you have the ability to do so, please improve upon my code. I am not a student of computer science. This RStudio thing is completely new to me, and the code that I made is pretty much guaranteed not to be the optimal solution for whatever you're trying to do. So if you are familiar with RStudio or are familiar with like computer science in general and you find ways to improve upon my code, please do so. Don't just copy my answer if you have a better way to do it. Secondly, if you're reading my thesis and you find any sort of error whatsoever, like you see a typo, you see some coding mistakes, you're digging through the stuff that I did, and you find anything that doesn't make sense whatsoever, please email me at the email address on the screen and tell me. It's a really complex project, and I probably messed up in some way in there, and I'm not sure where that thing is. So if you do spot any errors, please tell me, and it would help me very, very much. Thank you for listening.